Okay, so I'm Rick Pannenkoek. I will actually give you some background about the changes we did in the course of REST API for Sites 10.1. Oh, too fast. So in Sites 10.1, we introduced another API version for the course of REST, v3. So I thought it would may make sense to explain a bit what our entire version policy is for the core service REST. And so as you can see here, the header that's part of the Swagger UI. And so you see there's now a v3 API and OpenAPI spec as well. You also still see a v2 and a v1 spec, and that is basically what we call a side-by-side API versioning strategy we're using. And so in Sites 9.6, we had the first public API, course of REST public API that had version 1.0. And in Sites 10.0, we introduced the version 2.0, and now we're introducing a version 3.0. Yeah, make you think, okay, so we're introducing new versions in every release, but that's not our intention per se. And the idea is that we will create a new API version if we have to do a compatibility break. And just so happened that that was the case for all the past 3 releases. But so the idea is, yeah, so that if we want to, well, want to make a change that would entail a compatibility break, we are not changing any of the existing released API versions. We just keep them and just add a new API version next to it. And so the existing API versions will just be 100% compatible, basically. And it also means if you already created something that interfaces with the core server REST API, well, it will be against one of those older versions. And after an upgrade of Tridion Sites, you don't have to change anything. Basically, you can keep using those older versions of the API. It will be 100% compatible, so it will still work. Only if you then decide, yeah, but there's some new functionality in that new API that I want to use. Yeah, then you would have to what we then call migrate to the newer API version, and there we don't guarantee compatibility. So as a matter of fact, like I said, the main reason why we introduced a new API version is because there were some changes in there that were not backward compatible. Still, of course, we don't necessarily change everything, and so it should still not be very hard to migrate to the newer API version. But again, no guarantee that you don't have to change anything. But this may sound nice and simple. It's maybe a bit too simple. Let's make it a bit more complicated. And so actually there is a sort of difference in the approach we take for what you could call the routes, the endpoints, and the models. And the course of REST API consists of these two things, right? So you have a set of URLs, routes, endpoints, give the thing a name. But yeah, quickly you also work with models. That's just the data structures that are returned or accepted by those endpoints. And as you may know, Content Manager has a quite big model actually. So actually for us, it's not very practical to actually version that entire model. So our standard policy is actually that we say, so if we introduce a new API version, so you will get a new set of endpoints next to the existing ones. But we try to actually share the models between the definitions. So the models are actually not versioned by default. But we still, it is possible that we actually want to do a compatibility change that actually does affect the models and would break the models. So we do have an option to also version the models. But we only do that if that's really needed. So by default, the models are shared. And that may be a bit surprising sometimes, because if you look, for example, in the v3 API, one of the models we extended, we have an operation instruction, we added a property called recursive in context of promote demote. We'll get to that later. So there's just new property there, and if you look at the promote demote APIs in v3, you will see that property. If you look at the v2 or v1 API for that matter, you will also see that property, and that is because the model is actually not version. It would even be possible to actually use that property on the older API versions, but that's maybe overcomplicating things. So the idea is that new functionality, if you want to use new functionality, yeah, it should be on the latest API version. And the old API versions are there just merely for backwards compatibility and to prevent that you immediately have to recompile stuff if you're upgrading. But what we did do for that, so it is a bit confusing maybe if you look at the Open API spec, because or the Swagger API for that matter, because you will see newly introduced properties also in older API version. But what we did for maximum compatibility, you would actually expect if an older API client gets a new property, an unexpected property, well, it doesn't really mind, just ignores that property. But for maximum compatibility, we ensure that if so, we know which API version you're connecting with, and we also know which properties were known in that version. So basically, we just remove the properties that were not known in that version. So it's a bit of mix. The data is actually basically exactly the same as before, at least the data that you get back that you may otherwise your client might choke on maybe. But if you look at the spec, the Open API spec, you will see the properties are there. So that's just some complexity you have to become familiar with. By the way, it is exactly the same policy we're also using for the WCF core service. Things work exactly the same there, actually. So you may already be familiar with that. Okay, so in the v3 API, the main reason we decided that we needed the v3 API in 10.1 was because we felt the need to change the format of the error responses. And particularly, we were working on promote and demote APIs and found actually annoying difference in the results. Promote and demote APIs can give you a set of warnings or errors. And depending on operation instruction that may or may not fail the entire operation. And so there was actually an annoying difference in if it was an error, the format would be different than if it's not an error. For example, if you would do a bulk. So we said, okay, we should actually align that. That just makes it more convenient for ourselves and also others that are working with those APIs. But yeah, that change is not compatible with how it was in the v1 and v2 API. So enter the v3 API. And again, realized then, so we changed that error format, but really only if you're using the v3 API. So if you're still using v1 or v2, you get errors in exactly the format you got them before. If you notice the difference in the first place, right? It depends a bit on your error handling if you even notice the difference. But again, we ensured that on the v1 and v2 APIs, it's just 100% compatible. Yeah, and then all new functionality we introduced in Sites 10.1, we only exposed in that v3 API, and I will get back to the details later. That is about. What we also did, and that's also then in line with the policy, is we removed some routes that were deprecated in v2. And that makes sense, right? So it's a new API. It is, there's no guarantee that it's fully backward compatible anyway. So it's a nice occasion for us to just clean up and remove stuff that was already deprecated. And that also actually is interesting maybe to see that, so that's how basically deprecation in core service API work. If we deprecate methods, suppose that we have also now deprecated a few routes in the v3 API. And basically the deprecation means that if we in the future create a v4 API, we may or probably will remove those routes from that v4 API. We will never remove them from an existing released API. So the v3 API, even though they are marked as deprecated there, they will not get removed there. right? So you can be rest assured if you compiled something against any version of the API, and we won't change that API in at least not in a non-compatible way in the future. And again, saying in a non-compatible way, there's again this subtlety with the shared model. So it's, if you look at the v2 Open API spec, we now have in Sites 10.1, and you would compare it with the v2 API spec, which was the latest version in v10.0, they are not exactly the same. Right? So as a matter of fact, so basically there are some new stuff in the 10.1 v2 API spec that was not there in 10.0. But yeah, already explained. So yeah, that's just sort of side effect of a pragmatic versioning decision, and we are really doing our best to not provide actually unexpected data to down level clients. Then I want to actually pay some attention to lists, partially loaded list or contentless list, as we are a term we're using quite often internally, but I can imagine you have never heard about it, but it does become relevant actually for the v3 API. So let me explain what I mean with contentless lists. So for list in general, there's an interesting dilemma. So on the one hand, actually, we want to return as much data in that list as possible. And no, basically just to not have surprises of which list contains which data. And that is actually something you will see, you do see in the WSF core service. And that actually, so there we just decided per list, okay, what do we think that is a reasonable set of properties you want to have for that list? And that is basically what you get. And yeah, and the other properties you don't get, we leave them null, technically speaking. But yeah, that's per list. So you actually, it's also not super well documented, admittedly. So you just have to experiment a bit actually per list, which properties you're getting, which properties you're not getting. Yeah, and if there's anything you're not getting but you do want, then you have no other option than to just go do another round trip and get that additional data. And that's what we, on the one hand, we wanted to avoid in course of REST. We wanted to make it easier. Don't have those surprises. And what that also enables then is that we can actually, in the UI, you see in experience space, we have these custom columns. So it's even a user can choose, okay, I would like to see this piece of data as well in my list. And so by ensuring that we have as much data as possible in the underlying list, that becomes possible to do on all kinds of columns. So that's nice, but from a performance perspective, it's not nice at all. From a performance perspective, it's sort of the opposite. The fewer data, the better. And we realized that, I'd say as reasonably possible, we realized from the start saying, but if we really would return all the properties in the list, including custom content and metadata, which can be really large, right? Megabytes even. Yeah, then that's not feasible. That would use way too much memory on the server side, but it also would actually take way too long to transfer that to the client. We choke on it, so much data. So that's not practical. So it said, well, actually, so reasonably possible does not include custom content and metadata, and that's also where that term contentless comes from. But yeah, as we progressed, we also said, but there's other properties and not so much custom content and metadata, but for example, a workflow instance or an activity instance can have work items for all the items that are in that activity. That can be a lot, so that can also actually become a big property with similar problems as custom content metadata. So in general, actually, we came up with a set of properties we consider expensive, and these are not included in those quote-unquote contentless list. Which is a bit ironic because then the surprises are back, but yeah, that's just pragmatically to keep it also feasible from a performance perspective. So in general, in course of REST, if you retrieve a list, you're actually always getting partially loaded models. And models have a property called load info that actually can tell you if it's fully loaded or partially loaded. So if you would load a model file, an individual model, then that load info will tell you it's fully loaded. But if you retrieve a list, actually the load info will always tell you it's partially loaded. But still internally, to ensure we can return as much data as reasonably possible, we do something we call contentless loading, which is effectively we are first loading the list data with minimal information in it. But then we are going to individually load each list item. Well, we have optimized performance there, so we have now really called something a contentless load mode. So it is a bit optimized that it doesn't basically drops all the expensive properties as soon as possible in the process, not to waste performance on calculating stuff that we then discard later. But still, it is in essence rather a relatively expensive process, which we optimize as much as possible, and fortunately it can leverage a CM backend caching mechanism that we have. It's a long-lived distributed cache, so can just cache across request, and basically once cached stuff only gets expelled from the cache if you do something that would invalidate those objects. So there's cache invalidation. But yeah, that also indicates that so it definitely helps a lot with this, but it's not the fine. It doesn't solve all the performance there, of course, and you will still have cache misses if only because of cache invalidation. So it's not ideal from a performance perspective. And that's why in course of REST v3 we decided for a few, quite a few often used lists to introduce a details parameter that to actually give you more control over whether we use that contentless loading or not. And so we have details parameter with 3 possible values, ID and title only. Well, need I say more? It gives you the ID and title only, and that is definitely the fastest option available. Again, both in the processing that is needed on the backend, but also in the amount of data that has to be transferred over the wire, which may be quite relevant if you don't have a super high bandwidth connection with your front end. Then we have what's called with applicable action. That's a bit less obvious what that is. Well, yeah, it does have applicable actions. So that part is clear, I guess. And that is at least for UI and for experience space something that's often used to allow users to do stuff with the items in the list. And we want to predict what is possible with these items. It's called applicable actions. But actually, the idea of that with applicable actions is that we actually return you as much as possible without having to do the contentless loading part. So it's basically the maximum you could also get out of the WCF core service list, basically. And then we still have contentless, and we explained what that was. It is the slowest option of the 3, but we still made it the default for most lists, and mainly for making it the migration impact as low as possible. If you decide to so you created a client that let's say against the v2 API, and you now decide to migrate to the v3 API. Well, that client didn't know about this parameter, of course, so it wouldn't send it, and then the default is contentless, which is basically what it also was on v2. So and no changes there. So only if you explicitly specify it, you say, I know for my use case, I don't need all that data and just want it to perform better. Yeah, then you explicitly specify the one of the other 2 values. Only exception is actually the only new API we introduced in the v3 API version is the dependency graph, which we'll get to back to later. So that actually defaults to ID and title only, just because it can be so big that's the safer default. But you see, so we introduced it on the items list, so just basically used for navigation to just give you items inside another organizational item or publication. So used to build a navigation tree, the blueprint hierarchy, the where used list, dependency graph, which is kind of where used in itself. Get back to that, and publish transactions list, also known as publish queue. And then there is something interesting with applicable actions. Now, in general, we have something we call list info, which we did not expose in Course of REST in earlier API versions yet, but we do now in the v3. So we also have that in the DBSF core service. And so we have some data that, so what we return in list are typically, it's just entities from content manager, components, pages, stuff like that. But we have some data that does not really belong on those entities themselves. For example, if you do a where use list, then we have a command to tell you, okay, this is only old versions of this item are using your item. What we return in the list, actually, it's already aggregated. We don't return all versions individually, because then you could maybe figure it out yourself. But we return one list entry representing, well, one entry in the list. That is obvious. But I mean, so that it is actually, we just return you one version, if you wish, of an item, but it represents. So we do still want to explain that, but this is only old version of this item, and actually, to be precise, these versions of this item that we're using the item you asked the list for. So that's just some additional data that applies to list entries, but not so much to the entities in the list. So that's for that we have that list info property that we can put this additional data in. And we're now exposing that in the v3 API as well. But there's something interesting that this data is only applicable for list entries. But technically, what we do for contentless list is we start with list entries, but then we're just individually loading each item. So we're actually losing this information in the process. So for now, we just accept to say, okay, but that's just what it is. So if you want to have this kind of list data, you should actually not use contentless. You should use with applicable action. And that's actually a piece of information that with applicable action can give you more than contentless can. So that's published transaction list is another example where we have an item path, for example, which is not a property of the published transaction itself, but it's a derived property, but still it's useful to have that in your list. So available via list info, but not directly on the published transaction. And that brings me to dependency graphs. You see a real life dependency graph here of the British royal family, but that's just an example. So dependency graphs can best be described as multi-level where used. As a matter of fact, what we technically do under the hood is we just run where used list on multiple levels and aggregate the results. And then you think, so the positive side of that is that so it also really triggers where used events. So if you would have event handlers that do something with where used list, in general, you can create event handlers that do stuff with list, add entries, remove entries, modify them. And these will also kick in for this dependency graph. So you don't need specific entries then for this API. It is really just a multi-level where used. Then you make think, well, why is that so cool then? I can also do that myself. Well, to some extent that is true. But the big thing is that first of all, this is going to be in a single round trip. If you would do this yourself, you would do a round trip to get the top level where used, and then for each item you would have to do round trips to do the where used, there where used, and so on and so on and so on. So you quickly end up with a lot of round trips. And this is all done in a single round trip. And so we created an endpoint where you pass in the ID of an item. Can be any kind of item that supports where used, including publications. And yeah, so you can actually also specify the direction of the where used. So do you want the used items or the uses items? And we return you the results as a tree structure. So you really can see in the results if is it the direct dependency or indirect dependency, and then on which thing. If you say I just want to show a flat list to my user, you can do that. Of course, you can flatten that list. And that's, by the way, also the context, a context where we introduce this API. It's the ability now to do recursive promote. That is basically a use case in our own product, and where we're using this API to show the user, okay, if you're going to promote this, we would also have to promote these other things. That's just a flat list, but a tree structure under the hood. Another thing where just doing several where used, well, it's not as simple as it sounds, is you could have cycles. And so actually, if you look at the dependency graph, well, it's just that. It's a direct graph. It's not a tree per se. We do return it as a tree, but it is not. So actually, in case that you have a cycle, such as in the picture, actually, if you're not careful, you end up in an endless loop, right? Because you're basically giving what A is using. Let's say it's an example where you use uses. So A uses B, and B uses C, and C uses A, and A uses B, and so on and so on. So yeah, you don't want to get into that endless cycle, of course. So you have to detect cycles and stop expanding there to a point where you say, okay, but I've already returned you this thing. Another thing which is, well, a bit less problematic, but still makes sense to do is what you could call tree pruning. So if I do where used, multiple level where used, somebody would have to mute. Okay, it's better. Okay, so if you suppose I do again this dependency graph on a component, it uses multiple other components. Well, components in turn use schema, but yeah, multiple of those components, or if not all of those components, may actually use the same schema, and so it would actually be a bit overkill to return that schema and all its dependencies again for all those components. And so what we do is, if we see, okay, we already returned you an item somewhere else in the dependency graph, we're not returning it again and again and again. And we just give a reference and say, okay, but this thing is just, yeah, you already know, go find it somewhere else. And for that purpose, what we return is a tree built of dependency graph nodes, and dependency graph node can have, well, basically has dependencies which are dependency graph nodes, so you can just build an endlessly large tree that way. The dependency graph nodes, they also have a property called has more that indicates there is more, but I'm just not returning you to here for, well, either because, well, you just see elsewhere, or because it's a cycle that you can not keep expanding that endlessly. And last but not least, we also put a result limit on this, because again, can imagine this quickly can become a really big tree actually. So yeah, you can't just return you arbitrary big tree there. So you can specify a result limit on this. This is the maximum size of the tree I want to have. But yeah, since it is a tree, that means that actually it's not that it just stops somewhere. Some branches of the tree may be cut off because of that result limit. It's okay, now we can't expand it further because of the limit. And again, then we have that has more property to indicate that it is cut off at that point. But it's lot of talking now about this nice new API in the course of REST. Maybe worth mentioning that that's not only in the course of REST. We just made it available in all the public CM APIs. So the new course of REST v3 endpoint, also in the core service, the WCF core service, which by the way also has a new endpoint / contract called 2023-01, and it's also available in the tom.net. Now that brings me to a screenshot that should remind me that I can do a demo. I think we're quite early, right? So I have some time to do this. Okay, go away. You see, if you go to the Swagger UI, for example, so under list there is now this new endpoint dependency graph. It has some properties I already mentioned. So what is the item you want to start on? Basically, what is the direction? Do you want to use the items or the ones you are using? And then recursively, the result limit, the details, which defaults to ID and title only. And let me also demo that because it's hard enough to see. Get an overview of the results if you put the minimum amount of data in there. The result limit, you cannot specify it, but then still you have one, then it defaults to 1000. There are a few additional things. Well, there's in general, basically, there's just the filters you could also do if you do a single level where you use listed. So you may not be interested in all the item types, so you can just filter out some item types to again prevent having a larger result than necessary. You see, there's also something interesting called the context repository ID. But this is again because of our use case for the promotes, something that we needed. So okay, so we want to find all the items that this item is using, and then recursively. But if they already exist in the destination repository, then there is actually no problem. Then you don't have to promote them, right? So we want to filter that down. Good. You have the same capability if in the API if you have a use case for it. Yeah, if you execute this, then you get something like this, and it's easier to show it in something that I can expand and collapse. And so you see, you get a top level dependency graph node, which then represents the item you specified. So I did it here on a publication. So you just get some information, ID and title only asked for, of the publication itself, but then you get dependencies as well. And so these are the direct dependencies. So this is what they were used on the publication. And would also have returned you, at least the first level. So I have a few, but let me actually see if I expand this one, you see, yeah, it's kind of just recursion, right? So it's just going deeper and deeper and deeper and deeper. And you also see here, for example, I have it's hard to see again. So I end up with schema here. And that schema uses a category. And that category uses itself. That's remarkable, but that's our legacy. We really have that. So actually, we have some categories typically have actually a link to themselves. So here you have a cycle basically. And so you see the category here is returned, and then there's a dependency itself. So here you see that category returned has more as false, but here it's returned again. So we do still tell you, okay, by the way, this category has itself as a dependency, but then there has more true. So actually you could continue now, but then you would continue forever. So we don't just say, okay, there's more here, but basically you have all the information you need now in this graph. And that actually brings me to the end of this session.